thank you for having me along. It's great to be able to speak to you all today in this fantastic building. Before I begin, sort of picking up on a couple of things I've heard this afternoon. One of the downsides of going last is the fact you hear everybody else's talk and you think, I was going to say that and I was going to say that. So just picking up on a couple of things. The social engineering aspect, which is interesting. I was on the train on the way here yesterday and was listening to somebody. She was having a phone call beside me, and I'd virtually worked out who she worked for, the project she was working on, and everything, and she had no idea who I was sat beside her. So, yeah, people being careful just with data and just what they pass on. The other thing, sort of on passwords and things like that, an example going back to a previous company, they decided that they were going to make their password policy more secure. And the way they did it was to stop us from we had to change our password every 3 months in the past, and we couldn't use the same password for 2 years. They then changed the policy. You had to change it every 2 months, and then you couldn't reuse a password for 3 years. Okay, more passwords, more frequent. So I spoke to the IT manager and said, how do you get around this? He said, it's easy. I have one password and a number, and I just stick it on a Post-it note on my laptop. Yeah, okay, so if the IT manager is breaking security, you know it's not easy, and you've got to make security as easy as possible for people, and so that they can use it in what they do. So who am I and who are Doulos? That's one of the things. Doulos itself is a company founded in 1990, 4 founders who, they set themselves up to give, well, first of all, consultancy, and then the training became a big part. So we'd run a lot of training courses around the world, UK and well beyond. We do it either in person, online, so with real people we're talking online, and we also have on-demand courses as well you can have over the internet. And we cover a lot of different subjects in embedded systems, Linux, you got there, machine learning, and hardware design, which is where we really came from. 2 years ago, the founders retired and made us into an employee-owned trust. So we've all invested in it, and I've got some colleagues in the room, and we definitely are invested in the company. Based on my background, I teach embedded C and C++, Python we've got on there, embedded system security, which is where I come from on this, and then coming next year, a couple of new hot topics, Rust and Zephyr. And as part of the job that we do, we meet a wide range of designers. You can probably imagine we see people at all stages. Another interesting little anecdote when we're sort of going through on here, with Python, where the way we teach the Python course, it's got a button for ChatGPT. And we don't teach it, sort of teach people to use it. I was teaching a group of designers, they're teaching them Python, and they started having a competition. Could they get the answers to our labs in as few lines as possible? And one of them decided to use ChatGPT to do it. And the interesting bit was the answer he got to one of the solutions was a single line answer to all the code, and it said, and by the way, this might not be the best answer. ChatGPT even recognized it, never mind anybody, the designer himself. So, AI, useful, but use it with care on there. So it is very eye-opening what we do. And as I say, it's the weakest link that's involved here. That's, it's all very well securing the front door of your house, make it look like Fort Knox, but if you leave the back door open, well, people will get in that way. Taking a real example, I came across a company, they had secure updates, encrypted firmware, signed firmware, and I'm thinking, this is pretty good. Yeah, be good at that. And then I said, but of course you've got no default passwords in the firmware, have you? And they all started looking at the floor, and so I said, come on, what have you done? And they said, well, we have an engineering password, and it's burnt into the flash. It's common. Okay, and what can you do with that engineering password if you've got it? You can do anything. Right, okay. So why don't you change it? Why don't you have different passwords on different products? And the funniest bit was they said, because everybody knows it and we can't change it now. Yeah, so even though they did absolutely everything right, and I assumed that it was going to be a nice, easy job sort of talking to them about security, but they then turned around and said, well, actually, we've got this, this same password. And a lot of people we come across think that security just means encrypting stuff. It's an interesting sort of thought that in our embedded system security course, it takes us 2 days to get onto encryption, and people think that that's what we're going to do on the first day. But it's not. You're protecting the data. You're protecting the IP that people have got, their code. You've also got to prove that everything works correctly. So in the idea of certification and so on, yes, it costs you money, but you then have to have the ability to prove to your customers that everything is fine and all the code is working. So, yeah, there's a lot more to it. And yes, encryption is a part of the process, but it's not the only part. I'm also stunned by, I realise I'm preaching to the converted here, but there is a shocking lack of awareness when it comes to the acts and the regulations and so on. And I was teaching somebody a couple of months before PSTI came into force this year, so February time, and I told them about PSTI, and they were making products for a UK market, and they said, we knew nothing about that. They then got the technical director in, who stood there, and he listened to what I had to say, and he said, but it won't affect us, it means nothing to us. And yet they were making products that were for the UK market, and was trying to make every excuse possible not to have to comply. And you think, that's crazy. So despite the fact we're all here and we're all listening to these talks and whatever, the whole messages still have to get out and still have to be told to people. And that's one of the things, I suppose, that feels a little bit horrifying at times, the fact that we've got to get there. Also talk about, or in our courses, we talk about security and good design. Now, the majority of places where security bugs and security faults exist are in bugs. We talk about buffer overflows and things. Like I say, everyone's stealing my lines in all through it. But if you've got a bug in your code, how can you prove that it's secure? If you're releasing something that's potentially got a bug in it, how can you prove to somebody that it's actually not got a security fault as well? And the answer is you can't really do that. You've got to get your code as bug-free as you can. I mean, it would be lovely. If we could find a way of making code 100% bug-free, we'd all make lots of money and we'd sit on Caribbean islands, wouldn't we? But you've got to be able to show people that your code is, to the best of your abilities, bug-free, and then there's no ways of getting in. One of the examples we use on our first lab on our courses is to show people how a very, very simple buffer overflow and about 10 characters on the UART terminal can make the program run whatever you want it to run. You expand it to about 20 bytes of buffer overflow, and we can actually make it run code that wasn't even programmed in the device and without leaving a trace. And that's enough to frighten a lot of people. We talk about the course being an exercise in paranoia at times, but it can be incredibly worrying when you see it. Something we also deal with in the course is just the act of writing the code in the first place. When I was teaching at university, I probably was hated by the students. It's one of the good things, I suppose, if you get hated by the undergraduates at some point. But I used to tell them that I would take in a printout of the code that they'd written. I know most people don't print things these days. And the first thing I would do is I would read it. And then I would give marks. And I would deduct marks for bad code. And some people, yes, I told them that they would have got more marks if they hadn't handed anything in compared to what they did give me, because it was totally unreadable. But the point is something like we've got up there on screen. Int x = 1, set x to 1. Well, the compiler knew that. There's nothing that's in that line of code that the compiler didn't know. There's a variable called x, and it's 1. What's x? Why is it x? And people forget that sort of thing. It's very, very basic, And you might be sitting thinking, well, okay, this is fine. I don't do that sort of thing. But a great number of people do, and it's quite shocking at times. When people will write something like that, and they don't use meaningful names in their code, or they do some fairly crazy things at times. An example I always use is, what's the difference between a variable called s and a variable that's speed underscore mph? I don't need to tell you what the second one does, because it's a lot more obvious. The trouble is, that something like this, you can get the code out the door really, really quickly, but at the expense of readability and maintainability. So the sort of things that I always ask people as well, do you check all the simple things? Do you do the simple things? Do you check return statuses every single time? And if you don't, who does? Well, the answer is nobody, because the statuses that get returned from a function for your benefit to tell you whether something passed or failed, that's where some of the problems can lie. Do you trust your users and trust your user input? That was one of the things we have in the first lab that we do. But there's plenty of other examples as well. You mentioned SQL injections, but I've known of companies who thought they were so secure. Barbed wire around the factory, the lot. And a simple SQL injection revealed everything about the company. And that still happens today. You just have to assume that a user can and will do anything. And whether it's the user doing it deliberately or not, that can still happen. You can imagine where you're working on something with the user interface, you have to be able to simulate everything they were going to do. When I was a proper engineer, many, many years ago, we went through 3 levels of testing. The first level was in engineering. Could we use it? We put the kit gloves on, did it still work? Then we would get somebody and get them to follow the instructions, our user guide, would it work? And then we would give it to the technical director, and that was the one we feared the most. It would come back with a sheaf of notes of failures. And the typical answer to, is a bit like the mountaineer when you ask them, why did you do that, Jim? Because I could. And his view was that if he could do it, so could a user. And we could decide whether to fix it or not. So, you just have to assume that anything can happen and work it into your design. Have you ever had the Monday morning bug? It's all been working fine all week. You switch it off, whatever it is you're designing, go home for the weekend, and come back on Monday morning and nothing works. Or it doesn't work like it did on Friday afternoon. That can be something as simple as failing to initialize variables. You did it fine all week. It was working a treat. The variables got the right values in, and you've been using it over and over again. Switch it off for the weekend, because you obviously want to save electricity. Come back on Monday morning, and everything's random. And that happens so often, unfortunately. And you think, this is all simple. We do that. But the thing is, it's very easy to have these missed when you're working. And again, it's very easy for people to put those bugs into their code. I think the final thing to talk about is the secret test modes. People leave these in and think, nobody's going to press 3 buttons while standing on their head and get into that mode. But people will find these little things. I've spoken to customers in the past, and this was in a former life as an applications engineer, where they say they can release a product and within 2 weeks the internet has got articles telling them how to upgrade the products that they've sold, doing things that they didn't even know were possible, having developed them. And it was all largely because of the fact they'd leave these test modes in. People leaving pads in to connect debuggers because it was easy and it was convenient. Quite incredible. And you're thinking, well, okay, we don't do some of these, but you only need to do one of them. And there's a bug, and there's a security hole that's in there. Don't ignore the compiler. Something I always say to people is the compiler will let you get away with murder. C and C++ compilers will let you do all kinds of horrible code. I'm sure we know that. And you just put in a typecast, it's fine. It will just convert that from one to the other. That's okay. But as I always tell people while I'm teaching them, if the compiler thinks what you're doing is bad, it's got to be horrendous. Because if the compiler says, actually, this is a bad idea, well, it's got to be bad, isn't it? So, never leave warnings in the code. Try and find out why they're there. Definitely the last slide. You want to follow a framework at some point. If you are trying to design something and you've got to follow the checklist, or sort of the example that I give is like a pilot. Before they try and take off, they'll follow a checklist. They'll be setting on their kneeboard. They'll tick off the items effectively as they go through. That's what you need to do with the security and with your design in general. Obviously, there's the IoTSF framework that you can use. Great place to start. As you heard, it's been updated. Now go to the online section. But you should work in security. I'll just tell people that security should be treated like we do any of the other functionality in the design. We've gone through a process about 30 years ago where people were starting to build quality systems and things like that. Security should be treated the same. It's another part of your functional requirements, and it just makes life a lot easier when you build it in that way. So that's, I think, about on time. So that's it. Fairly short presentation from me. That's the sort of areas that we cover at Doulos. We have a stand upstairs, this end of the building. Come and see us. Come and say hello. But yeah, thank you very much. Yes.